beer, wine, cider, spirits, potable ethanol, anything that you can do to ferment alcoholic beverages. That's what our business is. Today, obviously, I will focus on yeast. So what is yeast? Yeast is a sexual organism. It's quite small. It belongs to the fungus clade. If you look in the tree of life, in nature there are about 200,000 species available. That's an estimate. There might be more. And industrial strains only represent a small portion of this natural diversity. So I estimate a few hundred, maybe 1,000 strains are available on the market. So let's talk about classic brewing yeast. I'm sure you all use these two guys, Saccharomyces pastorianus and Saccharomyces cerevisiae. So the pastorianus is the cold bottom fermenting yeast. It prefers cold, and is, in general, the fermentation is quite slow. For top fermenting, it's the opposite. It floats to the top. It prefers warm, and those fermentations are normally quite fast. So if you look at our range of yeasts, we have 15 dry yeasts, 3 lagers, ales, and also a new range, which is shown here. I'm back here now, sorry. The SafBrew range, which are more specialized yeasts. And today, obviously, I will focus on LA-01. As you can see here, we also have bacteria, a new product, LP652 for kettle souring. We have functional products like spring blanch to create and maintain permanent haze in beer, and fermentation aids like spring firm BR2 to help you with nutrition if you have a brew with low nitrogen content, for instance. So if we look at the total diversity of fermenters yeasts, I cannot go into detail, unfortunately, but the take-home message here is that in our portfolio, the genetic diversity is quite remarkable. It's very diverse, and basically it comes back to different clades. LA-01 clusters actually in the clade of sake yeast, which is quite extraordinary because HA18, which is a yeast specifically for barley wine, very high alcohol, is actually in the same clade. So what all these yeasts have in common is obviously alcoholic fermentation. So what happens, and this is very basic, obviously, you convert glucose into CO2 and ethanol. So one glucose molecule is converted into 2 CO2 and 2 ethanols. If you look at it in mass, and it's about 180 grams of glucose is converted in 88 grams of CO2, 92 grams of ethanol. So it's kind of 1-to-1 ratio. A bit more in detail, you start with the malt, you do your mashing, and you end up with fermentable sugars. Composition is normally around 10 to 50% glucose. Majority is maltose. You have some maltotriose and dextrin. So in fermentation, as I just mentioned, you convert to ethanol and CO2, but also you produce glycerol, you produce some acids, you produce a little bit of biomass. About 5% of what you add in sugar is converted into biomass, and you also produce aromas. Some sugars will remain. It's a bit depending on the yeast strain you use, like dextrins or maltotriose. So very important, what people tend to like is the aroma of different yeasts. So this is basically the same as you just saw, but a bit more complex. So you start with a sugar, you make ethanol from that, which is excreted, obviously, but you also make a lot of nice flavors. Most important ones, acetate esters like banana flavor, solventy flavor, some like spicy notes like 4VG. Some are off flavors that you can actually quite easily remove. Some, like the sulfur compounds, are a bit harder to remove in fermentation. But basically, this is different for each yeast. So to come up with some clarity, we did a lot of baseline fermentations, and you can find this image in our tips and tricks. Here you see the links. So the question is, where is LA-01? Well, I just positioned it somewhere here, and I will discuss now further on the trials we did with this new yeast. So SafBrew LA-01 is a Saccharomyces cerevisiae variety Chevalieri. So last year or 1.5 years ago, it was still called Saccharomyces chevalieri, but they renamed and reclassified the yeast now as a Saccharomyces cerevisiae variety Chevalieri. The main characteristics of the yeast are that it's a maltose negative strain, which means it does not ferment maltose or higher sugars, as I will show later. It produces some aromatic compounds, and it produces a little bit of phenolic, so a little bit of spicy notes. So before we selected this yeast, we did obviously a trial with other potential candidates. So we compared the LA-01 with Pichia, Ludwigi, Del Brucchi, and Rucci. The protocol we used was 100% Pilsen malt. We did a 12 Plato wort at 25 IBU, mosaic pellets. 65 degrees for 15 minutes, 73 for 10 minutes, so quite standard. And then we diluted back to 8 Platos or 16 IBU to reach a target of 0.5 ABV. Actually, we did different dilutions. We did 2 temperatures, 22 and 10 degrees, and I will show some results of this trial. So first of all, simply looking at final ABV of the different strains. So they are all around between 0.6, let's say, and 1% at 22 degrees. There is some heterogeneity, like the Torella Spura and the Ludwigi are both maltose positive yeast actually, but they grow very slow. But because of this maltose positivity, they are still able to ferment maltose, although very slowly, but you still have a risk of over-attenuation. The Rucci and the Pichia do not consume all simple sugars. That explains the little bit lower ABV. And as a result, you might end up with a beer that is too sweet or more sweet than the others. And then the LA-01, it stops like the other ones, but this one is maltose negative, so there's less risk of over-attenuation. We also did tastings, and because I only have limited time, I'll go through this quickly. The Del Brucchi produced quite a neutral malty and worty beer. The Ludwigi was quite nice, balanced, fruity, but it had a slight touch of DMS. And the Rucci produced in our experiments a lot of off flavors. And then the Kluivert produces extremely fruity beer with extremely high levels of isoamyl acetate, so the banana fruity flavor. And this resulted, to our opinion, in our sensory panel, in very poor drinkability. It was simply too fruity. The LA-01 produced nice beers with a slight phenolic, so spicy note, and had no defects. So based on these results, we selected LA-01 for further testing. The tests we performed were 50 gram per hectoliter pitching rate. We used Weyermann Pilsner wort at 15 Plato and a fermentation temperature of 20 degrees. So the first results, I'm showing here fermentation kinetics, so time versus ethanol concentration at different dilutions. So the yellow one is 6 Plato, the gray is 8 Plato, orange 10 Plato, and the blue one is 15 Plato wort. As you can see, you reach the limit after about 70 to 80 hours. Then the fermentation was done in all cases for all gravities. Apparent degree of fermentation for the different gravities is around 13 to 14% in our experiments, which is quite obvious if you think back a few slides. The amount of simple sugars, glucose present in malt is only 10 to 15%. So this is the apparent degree of fermentation that you would expect, because this yeast only uses simple sugars. Talking about sugars, so here on the y-axis you have sugars in gram per liter, and here you have the different original gravities. So the initial wort which has a little bit of fructose, a little bit of glucose. The majority is DP2, which is maltose, and we also had some maltotriose. And as you can see, in all cases, the fructose is used. In 15 Plato wort, there's a little bit of glucose left, but probably it's just because we stopped fermentation after 70 hours. So if you leave it for 80 hours, this will be gone completely. Because you see at 6 Plato wort, there's no simple sugars left anymore. And obviously this is the dilution that you get from the original gravity. So you see the maltose concentration and also the maltotriose concentration is going down linearly. So in short, simple sugars are fermented, higher sugars are not fermented by this yeast. If you put the original gravity versus ethanol concentration, so final ethanol concentration in the graph, we find a nice linear correlation. So if you want to reach 0.5 ABV, you need to make around 7 Plato wort. Aromatic compounds at the different gravities, we only measured a few. In the initial wort, we measured a little bit of acetaldehyde and a little bit of isoamyl alcohol, so this is also fruity banana, just a little bit. Not sure where that comes from, but at the higher Platos you see the majority is isoamyl alcohol and also some acetaldehyde, which is a green apple. This one was above threshold, but most of them are below the flavor threshold. So it's quite neutral, actually. Then the impact of temperature. So we also did the LA-01 at 2 different temperatures, 22 and 10 degrees. And we see at 10 degrees, it's not performing as well as at 22 degrees. So we recommend to use this yeast at somewhat higher temperature, because at lower temperature you might have some risk of an incomplete fermentation. Simply, this is a top fermenting yeast. It doesn't like lower temperatures. In terms of aroma, there was no significant difference between the two. It's as I mentioned, it's quite a neutral yeast. It just produced a little bit of spicy and a bit of fruity notes. So first conclusion, you can produce quite well balanced beer with this yeast. You preferably ferment above 10 degrees. It contains residual sugars. It contains all the maltose that was present in the worts. So that's why the beer is quite fragile in regard to contaminations. So this can be dangerous for your beer stability. And that's why pasteurization is really mandatory to stabilize the beer. So just a quick note on pasteurization. What is pasteurization? So one pasteurization unit, as they call it, is your beer for 1 minute at 60 degrees equivalent. So your beer has to be heated up to 60 degrees. And you can put that in a formula like this. If we look at the EBC recommendations, so the good practice guidelines from the European standard, they state low alcohol beer should be pasteurized between 40 to 60 pasteurization units. No alcohol beer requires a bit higher, so 18 to 120 pasteurization units. So what we did to test this is we again fermented a wort, again Weyermann Pilsner, this time at 25 degrees. And we cross-contaminated deliberately with T58. So this is one of our ale yeast, which is very robust. It always works. And we tested it, or we contaminated it in different quantities. So 0 as a reference, 10 to the 4th colonies per milliliter, 10 to the 3rd, and 10 to the 5th. So we added that, and then we pasteurized the whole lot at 60 degrees. So the sequence was ferment, contaminate, and then pasteurize at these levels, 25 pasteurization units, 50, 75, and 100 pasteurization units. And then after fermentation, we plated this on YPD media, and we checked the contamination. So the results of this are shown here. On the y-axis, you have your cell count. And on the x-axis you have the different conditions, so no contamination, a little bit of contamination, a bit more contamination, and a lot of contamination. And then pasteurized, I'm only showing 25 and 50 pasteurization units because the higher ones obviously also did not show any growth. So what we see at 25 pasteurization units, we measure cells. These can be T58 or a combination of T58 and LA-01. But at 50 pasteurization units, we don't see any growth on the plate anymore. So that's why we recommend to pasteurize minimally for 15 pasteurization units to stabilize the beer. So final conclusions, pitching rate 15 to 80 gram per hectoliter if you use this yeast. Fermentation temperature between 15 to 25 degrees Celsius is optimal. Apparent degree of fermentation around 15% if you use a traditional brewing scheme. Obviously, this is also depending on your malt bill and your mashing scheme afterwards. But on average, it should be around 15%. You produce about 0.5% alcohol at a 7 to 8 plate a wort. No off flavors. Pasteurization is mandatory, as I showed. Minimal 15 to 100 pasteurization units. You cannot use this yeast for repitching nor for re-fermentation. So only for your primary fermentation. In short, if you want to know more information about this yeast, you can find it online on our website. If you have more questions also about other things, please join us in the booth.
Do you know? Can you hear me?
Yes.
You've got some questions on the discussion. So
Okay.
let's have a look in the Q&A.
I will try. Thank you. Discuss.
And then click Q&A and then pick.
How does propagation? So I have one question from Daniel. How does propagation work for lager production? For larger production sizes, risk of infection. You cannot propagate this yeast actually. You should use it from the pack. If you start propagating, you have a chance of getting contamination more easily. So we recommend not to crop and repitch this yeast. More questions? Do you make pack sizes for 100 hectoliter? Yes, we do. We have this yeast available in 500 grams, but also in 10 kilogram boxes. You're welcome, Daniel. And as you see in this last slide, if you have specific topics, options, please complete the questionnaire. I will work with your response from that. Oh, we have a new question popping in. Will this be available in homebrew size packs? Martin asks. No, it will not, because most homebrewers do not have pasteurization capabilities. I'm an active homebrewer myself. And the only way to pasteurize is if you basically put your beer bottle in hot water for a certain time, but you don't know when your beer has reached the 63 degrees that you need to pasteurize. So for this reason, we decided not to come to the market with a homebrew pack. Will LA-01, another question from Bill, will LA-01 drop the pH to standard beer pH? In our experiments, the pH went down to about 4.8, starting at a pH of 5.2. So it's quite normal. Obviously, it drops a little bit less. And normal beer goes down to about 4.2, but that's obvious because you ferment more sugars, you ferment the highest sugars. So there's a small pH drop, but not as high as a normal beer. Cheers, Bill. So guys, I think the session is almost over. So if you want to talk, I'm available all day in the lounge or in the booth, just send me a message and we can discuss whatever you like. Also about other yeast, about New England IPA, about what happens if you brew at high temperature with a lager yeast, all stuff like that. I'm available all day. I see a lot of thumbs up. Thank you, guys.